Hello everyone, I hope you are doing well. In this video, we are going to discuss the rule of integration for exponential functions. We'll discuss the rule of integration of other functions too, but in other videos. Okay, this video is wholly dedicated to exponential functions because they are very important functions and their integration or some form of exponential function appears frequently in important mathematical derivations of physics and other areas of science. Okay, so learning their learning a correct method to do its integration is very important, and I'm sure that many of you students are very confused while doing its integration because you might confuse that why in some other cases that formula is valid and why we have to use some other method to do its integration, why we are not using that simple one formula instead. So all of these confusions will be clarified in that video, and all of these stuff occurs under a single rule that is general and it is applicable in every situation that you are given with. Okay, so learning that rule and the method to integrate the exponential function is very important. And for example, in the initial levels we are told about the integration of exponential function by this simple formula, which shows that its integration is equals to e to the power x. But this formula is this integration or anything that this formula is showing to you people is not giving you the complete information about the rule. Okay, this is only valid when for example you can see here that the integration runs over the x variable. Okay, and the similar variable appears right there, x variable appears right here, and e is the base. They are the many specific things that are holding here, and that is why the integration of this function is e to the power x simply. But if we are given it e to the power x square dx, then its integration will not be equal to e to the power x square simply. Okay, its integration will be different. And similarly, if we are given with some other base, for example, instead of e is a number, e is a specific number, which is I think 2.81 something like that, but it's a number that we represent by e because it frequently occurs in mathematical equations and all that stuff. That is why we have given it a specific name called as 2.81, and based on this e value, based on this value, the natural logarithm is established, and it works based on this. That is why we have given it a specific symbol. We usually give specific symbol to specific values that occur frequently in mathematical equations. For example, pi is an important number which has some specific values, 3.14 and so on. So e is a number, and instead of e, if we use some other number, for example 2 or 3 or so on, then for example if we have 2 to the power x dx, then its integration will not be equal to 2 to the power x. Why? And what will be the rule that we have to follow, that we should follow in every case that we are given it? For example, okay, we can't remember all of these integrations separately. We should know a rule based on which we'll find out the integration of exponential function of every kind. For example, of every function that appears on the exponent or any base that we have, and so on. Okay, in this video we'll see that general rule, and understanding that will make the things way easier. Okay, it will give you a sense of clarification that you can decide which method to use, whether the simple integration techniques works or not, and whether you have to use the complex methods to solve that integration or not. Okay, I have already uploaded the various videos on some complex exponential functions and their integration. Those videos are in a playlist named as integral evaluation. Okay, I have solved many complex integrals right there. You can check these out if you are interested, but if you are not, then let's begin with the video properly and see what the rule is. We write the rule of integration for exponential functions here, and then we'll understand it by using the notations and examples. Okay, rule of integration for exponential function is that the integration of exponential function of the form, for example, the form that I'm taking here is a to the power x, for example. Okay, and a is any constant and x is a variable. The integration of exponential function of the form e to the power x will be, the integration will be a to the power x, the exponential function itself, divided by natural log of base. Base is a here. Okay, a is called as base because this base has a exponent. There is something over it in its x, which is the exponent, and there is a base to x, which is a, and its integration will be equals to a to the power x divided by natural log of base. Okay, if and only if the integration is equals to this, if and only if the derivative of the exponent appears besides the exponential function inside the integral. Okay, we can write it in the integral form in that way. If the derivative of power is x here, dx by dx, let's say the derivative appears besides the exponential function, that is why we can write it as equals to this. Otherwise we cannot write it as like that. Okay, if the derivative of power appears besides the exponential function inside the integral, only in that case its integration will be equals to a to the power x natural log of a. Let us discuss it in further detail. So if we have an exponential function, for example, this is integration and we have some exponential function on some constant a. Okay, I'm not writing e here because e is a specific situation. We are considering here a constant number a. A is a constant, it's not a variable. Okay, exponential functions are those functions we define them as they are in the form of, like, if you have some constant number and a variable occurs on its power, then such situation such is called as exponential function. Okay, these are the exponential function in which the variable power occurs on the power of a constant number. That constant number could be e or some other number, and that is why we are using a. We'll use e afterwards, then I will show why this formula holds and everything like that. Okay, for example, we have a here and we have some power here. For example, the power is on x. Okay, and we have dx, let's say. All right, so let us have this situation, then its integration would be equals to a to the power x divided by natural log of base. Okay, its integration, this thing would equals to this, its integration will equals to this if and only if the derivative of its power appears here. Okay, for example, we have integration over x, that is why it's x here. If the derivative of its power appears alongside the exponential function inside the integral, then only in that case this thing could be written as this. Okay, if the derivative of its power is not here alongside the exponential function inside the integral, then you cannot write its integration to be this. You have to do some alternative methods such that this situation satisfied, and if this situation satisfies, then you can write its integration to be this. Otherwise you cannot write it as that. Okay, for example, let me teach you people about this rule based on this simple example, and don't be confused. It confuses you at first place when I just introduce you to this rule, but it's a very simple rule. Okay, and with example you people will comprehend it very easily, and that rule is applicable everywhere. Okay, for exponential functions. Now what I told you people, that if the derivative of its power, which is x here, appears alongside the exponential function inside the integration, only then you can write its integration to be equals to this. Okay, otherwise you cannot write it like that. You have to use the alternative methods to solve the integral. Only in that form you can write it equal to this, otherwise you cannot. Okay, so if we have e to the power x, now the derivative of power is x. Okay, derivative of x with respect to x is equals to 1. 1 is a constant number which is always there, so we can see here that 1 is there. And since the rule is satisfied that the derivative of power is appearing here, okay, is being multiplied to the function, that is why we can write its integration to be equal to the exponential function itself, okay, divided by natural log of base, and we have base e here, and natural log of e is equals to 1. That is why we can write it as simply that. Okay, so the integration of e to the power x with respect to x is e to the power x. All right, now let us see the other problem, which is e to the power x squared dx. What will happen if we have this situation? Now what we have to see first is whether the derivative of power appears besides the exponential function or not. The power is x squared here. You can see here its derivative with respect to x will be taken, and derivative of x squared is 2x. And we can see here that there is no 2x besides the exponential function, so its integration cannot be simply written in this form. We have to use the alternative methods to solve this integral. Okay, and I'll link that video in description box where I have solved this integration. Okay, the reason is the integration of its power is not here besides the exponential function. We'll discuss the situation later in the video where we'll see why we cannot simply multiply and divide 2x here. We can simply multiply 2x and also divide 2x inside the integral, such that the power, the derivative of the power comes besides the exponential function. But whenever x resultantly, even if we use the integration by parts formula, this integral doesn't solve to give a reduced form. It is a increasing or unsolvable integral. That is why we cannot simply do that method. I'll clarify this thing later in the video, so stay tuned. We'll discuss this thing again in the video. Okay, that is why we cannot use this rule here. Okay, we have to use some other method in order to convert this integral into a form that is solvable and can be written based on the rules that are predefined. Okay, so yes, now let us talk about this function. If you have 2 to the power x dx, the situation is like that. Now first we'll see whether the derivative of power appears besides the exponential function or not. So power is x, derivative will be taken with respect to the differential variable. Okay, so since it's dx, that is why with respect to dx, and x here is the power. So dx by dx is 1, and 1 is always there, so we can use that rule here because the derivative of power appears besides the exponential function, the main function. So we can write it as the exponential function itself, okay, divided by the natural log of base, which is 2 here. All right, so yes, now let us see some other example. For example, if we have a function like 3 to the power 5x, and we need to integrate it with respect to x. So the first checking is whether the derivative of power appears besides the function or not, and we have 5x as the power, and we have to derivate it with respect to the differential that appears in the integration, which is dx. Now d by dx of 5x, 5 will appear come outside of the operator, and dx by dx is 1, so it's 5. So the derivative of power is 5, and we can see here power 5 doesn't appears here besides the exponential function. And since 5 is a constant number, so we can simply divide it outside the integral and multiply it inside the integral so that the situation holds, because a constant number can be multiplied or divided inside or outside the integral, but a variable cannot be divided or multiplied. Here the variable came 2x, the derivative of power was 2x, and 2x, x is a variable here. We cannot simply multiply x and divide x outside the integral so that the situation holds. Okay, we cannot do that. We can do this, that we can divide and multiply variable inside the integral. Okay, but it will reduce the situation to the similar level of difficulty. It will not lead us to solve the problem. It will lengthen it. Okay, so a constant number can be divided or multiplied, so that is something that we have done here. Now the derivative of power appears besides the exponential function, and we can simply write the integration of this exponential function based on this rule. Okay, 1 over 5 is outside of the integral, so it will remain unchanged, and this whole thing will be equals to the exponential function itself divided by the natural log of base, which is 3, plus c, which is a constant. Okay, so I hope you all people now understand what to consider. E to the power 2x plus 1, all of these things will be solved under the similar rule, which is this: if the derivative of power appears besides the exponential function, then its integration could be written as a to the power x divided by natural log of a. Okay, if the derivative doesn't appears besides the exponential function, then you cannot write its integration based on this rule. You have to use the alternative methods to solve that integration, and this is the general rule of integration for exponential functions. Okay, I hope you people got the method, got the rule, the main rule, that if the derivative of power appears besides the exponential function inside the integral, then you can write its integration to be this, otherwise you cannot write it as like that. Okay, and due to this rule, integration of e to the power x squared dx is not simply e to the power x squared. All right, this is the complete description of the exponential integration of exponential functions rule. Okay, that is the complete description. If you have any queries or questions, you can ask me in comment section. I hope you got it.